Welcome to myprojectbazaar.com. Our product title is Low Power Techniques for Dynamic Comparator. Now we are going to discuss about our product abstract. So low power techniques to reduce the power consumption of dynamic comparator is presented. Using these techniques, the pre-amplified the phase of the comparators is stopped without any effect on the dynamic behavior of the comparator. So the power consumptions of the pre-amplifier stage, which is the main part of the total power consumptions, is reduced significantly. Simulation result the various comparison reveal of the proposed techniques in the power consumptions. The comparator or the key building of the block analog to digital converters. The speed of the power consumptions of the comparators play on the important role in the characteristics of the ADC. The successive approximate registers SAO on the flash ADC static comparator have been used in the post of the high power consumptions and the low speed. The dynamic comparator were proposed to reduce the power consumption of the comparison speed with the dynamic comparators and the pre-amplifier stage, amplifying the input differential signals. In the conventional comparator, during the latch process and after that, the large amount of the output characteristics capacitors of the pre-amplifier stage on the consume the pre-amplification stage for the preventing the operation of the pre-amplifier stage. When the differential voltage of the latch stage is large enough of the IC latch stage and the decision of the latch stage, the exact gate to stop the pre-amplification process. The exact gate reduces the voltage swing after the decision of the main output of the pre-amplifying stage in the pre-amplifier stage power consumptions with affecting the comparison speed. Now we are going to discuss about our product's flow diagram. So our product is designed in the Tanner 2 for the CMOS designing. So the CMOS design the process included in the PMOS and NMOS. So what are the comparator we get the processing the singular dynamic, what are the time the comparisons. So we give the input for the A and B, the architecture designs inputs the same time the both dynamic of the output we get the output for the in the CMOS technology. So whereas we used the CMOS including the NMOS and PMOS. First we are giving the PMOS connections in the parallel and the without clock and the input of the clock we get the some sampling output, we get the comparison process. So in this comparison process why we are this using the process we give the input for the A and B. The A give the process is A and B is equivalent, the process will get the same high process it means the high level means 1. At the same time A greater than B, we give the input for the A is greater than B is less than the process is the high level, it means 1. And the same time A less than B, A is the low and B is high level, it will be the zeros of the output is a low power output. So what is the what are the given input for like both input section that comparison and get the high level only for the output processing. This process we give the comparison. Again we going to the double tile designs. This process dynamic process. This process we get the output in parallel connection to the parallel connection into the CMOS and the PMOS. We get the output in the dynamic. We change the input bar A greater than or B and A less than or B. This process we get the output sampling process, the designing the double tile dynamic process and the bipolar designs. The bipolar design process we give the single input in the single output for the is a single process. So this process we give the checking the comparison every each and every bits are pulse and voltage processor. Then we get the output from the comparison model comparison in the process. Now we are going to see our product running procedure. This is our tool for the Tanner EDA 13 versions. So I have designed this process, have a little bit hide the process. The design is just I am going to the simulation setup. This is the central general setup for the settings. We do that transients for analysis and take the parameter options. We click around and double click the options. We must give it the stop transients for analysis. The giving the stop time 200 nanoseconds, and then maximum time steps 100 10 sorry 10, and print the start time zeros and print times at step 1. This all this process all the way should giving the process and then give some setups, and then we go into that start the simulation process. And it will be open the t-space process, and the waveform process also give this is the main output for this our project. This is a comparison process. So this is our project output, like this is the default clock plus the default 10111 conditions we give that, and the same time the output for that process, the comparison process will be shown that the little bit the zeros as once we did will be both that the simultaneously it will give the process at the same times. This process is a comparison process, and this also the input processing, and this is also get the clock additional clock the input process. This main output for the comparison process.